Okay, this is MAP4C. This is a bonus lesson for the folks that are maybe ahead um, in the geometry unit, already ready for their test or already written their test, waiting for your classmates to catch up. This is how we can use the TI83s to solve these optimization problems, these tough ones that we saw, the Toblerone bar question and so on. And it says use technology. For the most part, we've been doing spreadsheets, but we can do this using the graphing calculators. So the example here, we've got an 80 square foot garden, and it's against a house and has a rectangular shape. What dimensions will minimize the amount of fence required? And we've done this a number of different ways, and we'll talk about how we're going to use the calculator. So the idea, there's a house. Width and length, and we want to find out what dimension we should make this so we minimize the amount of fence we use. Notice that 80 square feet, this means this area has to be 80 square feet. And how we solve these questions in class was to set up a table, right? We'd set up a table, and the perimeter, the amount of fence that we needed, we can see is it's 2 widths and a length, right? And so we pick a value for W, figure out what L has to be to make the area the right size, and then we'd figure out what the perimeter was, then we'd pick the best one. So I'm going to do an example like that, and that'll lead us to the general case. So I don't know, on a spreadsheet we'd pick something really small like 0.1 or 1 maybe, but just to make the numbers easy, I'm going to pick 5 here. And so then I need to figure out what L is so that I get an area of 80, right? Remember, it's basically this little formula where I know that the area has to be 80. I've picked W to be 5, and then I'm going to divide both sides by 5 to figure out what L is. In this case, L is 16, right? So 80 to this is 16, and then I can figure out what the perimeter is. Well, it's 2 times 5 plus 16, and I got 26. And then I kept going, and I'd kind of guess, and hopefully I'd get the best one. And we were always worried about this because, you know, it didn't seem like it was very likely that we would happen upon the perfect answer. And that's true. And these calculations just seem the same. I was always dividing by the width, and I'm always going 2 W's plus L, and it seems like we're doing the same thing over and over again. And I'm going to show you how we can use the graphing calculators to do this and get a perfect answer, or fairly perfect. So instead of picking a particular number, what we could do is say, let the unknown width here be X. If it's X, then what would be the expression for L? Well, whatever the width was, I just divided by it, and that's what the length ended up being. 80 divided by 5, or 80 divided by 10, or 80 divided by X. Right? And so then the perimeter is 2 widths plus the length, which is an expression. See, now this is an expression for the amount of fence that we need, right? We want to make this a minimum. Well, the calculators are good at whatever expressions we give them. So I mean, what I'm going to do is I'm going to go to my calculator, and however you turn it on, whatever might be going on in the calculator, you can clear that. But we want to put that expression into the y equals part. So the first step is, and if you follow along in the calculator, I'll write down the steps later, so you can write them in the margin in your note. Press y equals, and then I'm going to put in this expression, 2x plus 80 divided by x. And essentially, I want to graph this so I can see where it becomes a minimum, where this expression gets as low as possible. And I'm going to, notice if I just press graph now, it could look in all sorts of different ways, and you could go ahead and try that. But I'm going to make some window settings. What would make sense for x to be? Well, if it's 80 square feet, obviously x can't be negative, so I'm going to put in 0 there. And I don't know, what would be the biggest, the maximum X that would make sense? I don't know, 10 or 15, maybe? 20, why not? Going up by X scale means how much I'm going up by. 1 seems okay, I suppose. Maybe I'd make that 5, so there's not so many ticks. As far as the output, what perimeter, well, we saw what kind of numbers we were expecting. 26s and 18s, and we'd hope that we get lower than that, but I don't know. We might want to go, well, let's start at 0 because it doesn't make any sense for the perimeter to be negative, but we could even go higher. We could say it might be as high as 50. Maybe it'll go up by 10s on this one, just for funsies. And then I'm going to press graph and have a look. So remember, this is an expression for the perimeter, the amount of fence. This is what the width was. X was the width, wasn't it? And I can see right there, that's the perimeter gets the smallest right there. And now how do I figure out what that is? I suppose I could try and read it off of this. Remember, each tick was worth 10, and that's how I set up the window settings. But the calculator can do this for us. So I'm going to actually show you 2 ways to get to the answer. One is just hit the trace button, and that puts you as a spider on the graph, and I can go as close as I'm just pressing the cursor keys and getting as close as I can. I'm looking for the smallest output, the smallest Y value, the smallest perimeter I can find. 25.3, 25.4, 25.3, 25.29. See, right in here somewhere, right? And I can see that I'm in the right area. So any of these values, it looks like X is around 6.4, maybe 6.3, in there. And unfortunately, it's sort of jumping around a little bit. So one way is using the trace feature, not just that but it still feels like we could get even closer to be more exact. And the calculator has a built-in function called the minimize function, and it's actually, if I press second function, trace, this gives me to the calc menu. If you see the calculate menu, I can pick the minimum. If I wanted to maximize something, well, I'd pick maximize or maximum. So when I select minimum and I just use my cursor keys, go down to 3, press enter, and then it's asking me, well, what's the left bound means what values do you want me to find the minimum? So I just got to make sure that I'm going to get this minimum value. So I just scrolled left a little bit, press enter, then it asked me for a right bound. So it's going to check for the minimum values between the left and right values that I give it. And then it asked me for a guess. In here somewhere was the best guess. I press enter, and then the calculator does something, and it comes up with the best answer. So I'm going to write that down. X is 6.3-ish. And I can see the perimeter, the best perimeter was 25.3. And I can write a statement there. Before I go on and do that, I want to write down the steps that I did. Okay, the steps that I did on my calculator. But once I knew what expression I was going to put in, I pressed y equals. I pressed the y equals button. That allowed me to enter the equation. Then what did I do? Well, I picked some window settings, and just by luck, I picked good window settings because when I pressed graph, my graph was in there. But you might have to go back and mess around with those. And when I put a box around something, that's actually a button on the calculator. And then what did I do? I pressed graph. And then I went and I tried to find the lowest value. I pressed trace. And now, remember, that gave us the value. That was this when we were the spider on the thing, going back and forth on the function. And this gave us this is the best way, I think. If you press second trace, that's when we got to that calc menu. All right? I went second trace, and that was the calc menu. and then second trace, and then I'm just going to say follow instructions. Pretty good, eh? I mean, way better than guessing on a chart like this, or even the spreadsheets. I think are a little bit confusing. So um, the garden should be X was the width, 6.3. What is this, feet or centimeters or what? Feet wide. And notice we don't know about the length, but there's an expression we got there for the length. So I'm going to have to do a little bit of more work here. And that's about 12.7. Long. And for this question, I'm not too worried about this should be a fraction of a foot or inches or whatever, but that's good. Now let's try the next one. I'm going to go a little faster through the next one because hopefully we kind of got the idea, and you'll see the calculator steps again. For just creating an open top toolbox that will have a volume of 10 liters. The box will have a square bottom. So I don't know what this is. All I know is the bottom is a square. So that's x by x. I don't know the height, but I do know that this is open. There's no material here. What dimensions will minimize the amount of construction material? And we've got that in a second. So again, what are we going to do? Well, let's figure out what we'll do with that value. The volume is 10 liters, but I'm going to want this in centimeters. Remember, 1 liter is 1,000 centimeters cubed. Hopefully you've got some of these committed to memory, or just from being alive you remember them maybe. Okay, well, also we've got this formula, right? It's a rectangular prism, a box. This is 10,000, the volume. The length is x. The width is x. And then the height is, well, h, we don't know. What this is going to help us do, remember, our calculator, we can only have one value to put in to our calculator, or in a spreadsheet, right? We have to have a formula that only has one unknown. This is going to allow us, x times x is x squared, to get an expression for h. Right? So if I divide both sides by x squared, it's kind of in the way. Getting a little bit sloppy here. So h is an expression. And now, what do I want to do here? What is this all about? I want to minimize the amount of material for Ferd's toolbox, right? So the surface area, the bottom is just a square, right? X times x is x squared, plus the sides. Now, notice how the sides are all the same. They're all x times h, so x times h, x wide, h tall. But h is that expression I just found. That's that expression right there. See, as soon as I get an expression that's got only one variable in it, over here I had two, so I couldn't put this into the graphing calculator. This one I can, because whenever, I'll just press the X button. And then this expression, I want to minimize. Again, this is a minimum question. It's not a maximize question, so we're going to be using our minimize key. So I'm going to put that into my graphing calculator. When I turn it on here, oops, that's what that was all about, excuse me. Let's go turn on. We've got all the stuff from the last one. You just press clear, get rid of that stuff. Remember, y equals is to get to this screen. And then I'm going to put this in. X squared plus 4x. Got to put the times key in here, I think. 10,000 divided by x squared. I put an end bracket there, start bracket, end bracket. And then I'm going to hit my Windows. Now, what would be good window settings here? Well, what would make sense? This might be more than, let's go up to 50. Maybe it's 50 centimeters wide. And the scale doesn't really matter too much, but I'm going to go up by 10s. Each tick will be worth 10. As far as the output, we don't really know, except for that it's going to be a pretty big number, right? Whoops, the the volume was 10,000. The surface area is going to be a big number too. So I don't know, we could put 10,000. Let's try 5,000. Again, if we goof this up, we can always go back and change the window settings just by hitting window again. So once I've chosen my window settings, then I hit graph, and hopefully, yeah, look, going down, there's the minimum right there. Lovely. And I'm not even going to press trace. I'm going to go straight to the minimize function. Second, calc, minimum. I want to find the minimum. Little left of my minimum. Press enter. Go a little right of my minimum. Press enter. In the middle. It's the guess, and then it'll give me an answer for X. So I'm going to say TI83 gives me X equals, what was it? It was 27.1. So the length and the width are both 27.1. I have to use my expression to figure out what the height is. The height is 10,000 divided by 21 or 27.1 squared. Jam that into a calculator and you get about 13.6. So then I can say, therefore, the toolbox should be 27.1 centimeters by 27.1 centimeters by 13.6 centimeters. Okay, to get the bonus, you have to show me this note and then show me what you did to go through the homework questions. And the homework questions is just following along the textbook, putting this stuff into your graphing calculator, okay? Glad you tried it. Hopefully it was a bit of fun.